Okay, let's talk about a bit for the assignment first, and then I think some of you may have questions about the assignment. For here, I have shown you already last round to download the traffic sensors, okay? And then if you download the full version of the traffic sensors, actually you will find the appendix as well as the original document, okay? Now in your assignment, actually we are going to design the road actually from the from the point A to point B, actually which will be the whole, part of the Castle Peak Road. So actually it's very difficult for you to look at the traffic sensors because actually you can see that this from and then to here, and then you have your role name. Like instead of checking from and then to for the role name, actually you can take a look to the plan on the traffic sensors. Okay. Well, actually, from the plan actually shows different locations of the Hong Kong Island, and then you just need to find the one belongs to the Castle Peak Road. So you can go to one of the plan, and then you can go to the part right here, and then you can take a look and mark it, and then you can see that actually along the Castle Peak Road there are different stations. Say, for example, you will have 5410, and then you have 5409, and then you have 5609, and then you have 5408, etc. So along this road, actually, you have different stations. And then for different stations, actually, you can also find the AADT for that. Say, for example, you have 2019 to 2020, the value. And then, of course, you have also the growth rate here. You can see the percentage of growth. And then, well, some of you may ask, hey, although this is the Castle Peak Road, and then this is from and then to. Now, it doesn't matter. I don't ask you to identify the location from and then to. You just need to design according to the so-called the station number. Say, for example, if you see there's a C2 here, you have a station 5409, then you just need to design according to the data of 5409 for this part. And then for the next part, you also have 5609. Then, of course, you also need to design for 5609. And then you have 5408, and then you also need to design for 5408. Okay? So for the whole road section, actually there are several different road stations. And then you need to let me know what is the thickness of your bitumen along this road. Say, for example, according to the data 54110, what is the thickness of the bituminous layer? And then according to the data, what is the thickness for the AADT at 5409? Okay? And you just, yes. Yes. Yes, you need to have the calculation for each of the station. Okay, then for each station, you should have a particular thickness for the results. Okay, so you should have a series of thickness at different stations. Okay, you know what I mean? That's why it's a group project. If you just decide for one thickness, then it is an individual assignment. Okay. Because actually along the road you have different criteria, you have different traffic data, and then there are several different stations along the Castle Peak Road. Okay, so for each data for each station, you should have one set of thickness for that particular station. Okay, so you can count the number of stations along the Castle Peak Road that you are going to reconstruct, and then you need to give me the related sections. OK， 嗱用廣東話講一次，即係話咧，你咁多個 station number， 每一個 station number 俾翻一個 thickness 我 ，OK， 因為唔同嘅 station number 有唔同嘅 traffic data， 每一個 station number 應該有一個 thickness 嘅 ，OK。So you should have a number of stations. Okay, design your thickness according to the data from that particular station. From this one, actually you can check the station number along the Castle Peak Road, and then you look back in your traffic sensors, and then you can know what is the AADT. Okay. But remember, for the AADT, for the growth rates, actually you can take a look back to several years before. Say, for example, you can take an average for 10 years for the growth rate, because right here you have just 1 year of the growth rate, okay? Maybe you can take a look to well, depends on your assumption. You may take a look to 5 years, or you can take a look to 10 years on the average growth of the traffic growth rate, okay? If it is lower than, I mean the traffic rate, you can see that sometimes it is positive, sometimes negative. But to be conservative, as we mentioned in the notes, you should give the minimum growth rate, okay? If the values is a negative number, or actually it gives you a very small number, so we suggest that you should give a minimum growth rate for a particular road sections, okay? You know what I mean? Because right now you just have 1 year of the growth rate, it may not be good enough. So I suggest that you need to take a look to the, because this is 2020 traffic census. There's another one in 2019, there's another one in 2018, etc., right? So there's a growth rate for each year. I suggest that you may take a look to several years growth rate and take an average of that. So you can estimate what is the growth rate on that at that particular road station, okay? You may say in your report whether you use a 5 years average or you will use a 10 years average. And then of course, if the average is lower than the minimum requirement that has been stated in the notes, then you should justify the, adjust the growth rate and then according to the minimum value as stated in the notes. Okay? Is it fine for you? Now I have extended, yes.可以，因為都係嗰係 standard section 嚟嘅。Okay, so you have the question is whether you can use the standard section in the highway drawings for your highway sections. Yes, of course. But I suggest that you can draw it one time by yourself. Okay, don't directly copy that from the notes. Okay. Try to draw it one time by yourself for the section of the road. You may just design or draw according to the standard drawing, okay, to notify the work on the roads, okay. For the average growth rate, I suggest to use the average of several years. 5 or 10 years depends on you, okay, but it should be reasonable. Because actually, if you just take 1 year's growth rate, it may not be good enough, okay? And then you may ask, hey, I have a negative growth rate right here, and then, well, for your design, do you think it's a reasonable or conservative way to design a road if you use a negative growth rate? Okay, if not, then you should use a minimum positive growth rate for the design of the road. Okay, agree? Okay, then I have extended the deadline for 1 week. Okay, so please submit it on or before next Monday. Okay, should be good enough for you for your homework. Okay, you are welcome to ask if you have any further questions. But it should be good enough for your homework, right? Yes. 我講乜嘢？用翻咧 report 嗰個都可以，或者用翻咧 report 嗰個啦。OK。Okay, you may use the the board members in your lab report. It is okay. And board 7最多7個啦，因為我見到你 lab report 最多7個人啊嘛，冇超過7個啦。咁你同lab report 嗰個 align 啦。So you should align with your lab report. I mean the number of members. Okay, and then I expect that you should give me a better quality if you have a larger group numbers. I mean, more group members. Okay, because you have more people. So I expect that although there's a rubrics, okay, but I expect that you should have a better quality because you have more members, okay? Okay, so is there any further question for the assignment? Yes, the lab report. There will be one more lab report that I'm going to pass to you. It's about the California bearing ratio test. But for that one, you do not need to come back for the experimental test because I have shown you in the video, and our equipment actually is out of order. Sorry about that. So I'll give you the data for the CBR testing. So for that one, I will pass you the lab sheet soon. So you have two lab reports to complete. One is about the soil bearing ratio, California bearing ratio, and the other one, of course, is for the Marshall test. Okay. Now you can submit your lab report before the end of the semester. Okay. So you should have enough time to finish your lab report as well. Now next week is the test. Okay, please come back and then we will have our test in 1011. OK， 下個禮拜一咧差完假咁翻嚟考嘅，咁唔該同學準時2點翻嚟就1比1。OK。So for that one, as I mentioned before, I will give you some calculations, mainly for the fitness, bituminous fitness calculations that you have just similar to your homework. And then there should be some calculation related to the mix, because actually it will be up to chapter 6, right? So you also have some calculation about the mix design, okay? So you should prepare for that. And then I'll give you the required formula, and then you can calculate accordingly, and then the graph, okay, if necessary. And then there are also some question and answer questions. Like if I ask you, what is the types of the road in Hong Kong? What is the difference between expressway and then the minor distributor? Okay, then you need to tell me what are they and tell me the difference for that. Now it is a closed book exam, okay? So not exam, it's a midterm, closed book midterm. Okay, so you cannot open book and then have your reference. So try to memorize some of the definitions, okay? Say for example, what is California bearing ratio test? Okay, please briefly describe the procedures. Okay, I may ask a question like this, and then you may let me know what is the purpose for the California bearing ratio, and then brief me about the way how to perform the test. Okay, and then for example, I may ask you what is the gradation curve of the aggregates for the surface course. Okay, what kind of gradation is required and why we need that particular gradations. For example, for friction course, we have open grade. Okay, why we need to have open grade? Because we want to have more space, and then for noise eliminations, and then for water drainage. Okay, so you need to answer something like this. Okay, so there will be some questions related to question and answer. Okay, I will ask you some details and then the reasons, and then there are also some calculation, mainly for the design. I mean the max design, and then for the fitness design of the highway. Okay, so be prepared, and then try best. 2 hours for the durations. Okay, it is a closed book test. So try to familiarize yourself about the way how to design for the mix. And then for the thickness calculations. And then for some definition, just try to take a look. And then you may express by your own way, okay? And then if the meaning is correct, then you still can get the mark, okay? No need to be exactly the same as stated in the notes, but the meaning should be similar. Then you can get the point. Okay? Okay, if you are okay, then we can talk about the famous last one. Like, if you still remember, last one we have mentioned about the horizontal curve, and then we have the tutorial about that. So we can take a look to the tutorial last one first, and then we will talk about the lecture today, and then to take a look to the tutorial again, okay? I'll share the document, so wait me for a second. Here are actually some tutorial for the safety distance. And then say, for example, for the first one, road safety generally involves technical and behavior factor. Please describe the different aspects concerned of these two aspects. Like this kind of way to ask can be appear in the exam or in the test, okay? So if in this way, so you need to tell me what is the technical aspect and then what is the behavioral aspect, and then what does it involve, okay? So for this one, if you still remember, for the technical aspect, actually it is about the highway design, and then about the road furniture, and then vehicle occupant protections like the safety belt, improved bumper design, and then the passenger side airbags, and then the vehicle accident avoidance, save for the braking system. For the behavioral, actually it's about the accident countermeasure and some behavioral actions like 2 seconds spacing between the vehicles. Okay, so this type of the question can be here in the test or in the example. Of course, in the test we just move up to chapter 6. So chapter 7 here will not be involved. So don't worry about it. Okay, for the question 2, actually we have mentioned last time, is about the stopping distance. But if you still remember, we have the so-called the stopping visible distance, or we can also call it the stopping sight distance. It is about the reaction times and then the braking distance. So actually you have the braking time, then actually you have to have your reactions. And afterward you will have your braking distance. So when you add them together, actually we call it the stopping sight distance or stopping visible distance. So when you look at something, then you can see something, then you will take the actions, and then you will stop your vehicle from hitting on the front side. So you have the so-called visible stopping visible distance. So last one we mentioned that if you have vehicle A hit on the vehicle B, and then you have marking of 90 meters, and then you have to provide a comment for the result of these investigations. So do you still remember how to calculate this kind of design for this kind of questions? If you remember, actually you have your the distance, or we can call it the braking distance. It's actually equals to the VD. VD is actually the design speed square and then over 2 mu g. Where mu is actually the friction coefficient and g is the gravitational acceleration. While actually you need to plus the so-called VD and then times T. VD actually is the design speed and T is the reaction time. So actually last round we have mentioned about this one, and then I think we do not need to cover it again. But for here, actually, we did not mention about the reaction time. Actually, you just use the VD square over 2 mu g, the braking distance. Because actually, when you try to brake, and then actually you create the so-called the braking mark on the road, and then from that you can calculate the VD square over 2 mu g. So actually, just put the 90 meter, which is equal to VD square and then 2 mu g. Well, mu is actually the friction coefficient on the road, and then g is the gravitational acceleration, then you can calculate what is the velocity of the vehicle. Okay? So you may assume that the value of the friction is equal to 0.5 here, and then you can calculate for the answer. And then you can find out what is the braking distance for 7 km per hour. Then you will know the answer. You know what I mean? I think last round we have already finished these questions. Okay, so I don't go into details for this. Okay, the government slogan says keep a safety distance of 50 meters from the vehicle in front. And then try to comment on the usefulness of this so-called cases. Say for the design speed is actually equals to 50 km per hour. Say the dry weather mu is 0.7 and then the wet weather mu is equal to 0.3. So it depends on the braking distance plus the reaction times. Could you please, right now we can try what is the your comment if you have these two conditions. So if it is 0.7, what should be the distance? And then 0.3, then what would be the stopping distance? Can you try to calculate by yourself? Now, the stopping side distance is not difficult. It's actually the reaction distance plus the braking distance. So actually it's V for the design speed, and then plus the time. And then for the braking distance, actually it's V squared and 2 mu g. This is the distance. So if it is 50 meters from the vehicle in front, so design speed of the road section is 50 km per hour. So is it safe for the dry weather, and is it safe for the wet weather? Can you try to calculate on yourself? So 50 meters is enough. But remember, for this kind of question, first of all, for our equations, actually we will use meter per second instead of km per hour, as I mentioned last round. So for this one, actually you need to turn or change your speed to meter per second. Then you can calculate actually whether 50 meters ahead is okay or not. So for the first case, actually it is a dry case. So we should use the values of 0.7, right? So assume that your design speed actually is equal to 50. Then you need to turn it back to meter per second, right? So 50, what is the speed of the vehicle in meter per second? Usually 50 divided by what? 3.6, right? So what is the value? So can somebody tell me? Okay, 13.89. Okay, meter per second. So we have 13.89 right here. And then always saying that we have 2 seconds for safety distance. So assume that our reaction time is 2 seconds. Okay. And then we have Vd squared. Vd squared is again 13.9. And then we have our values is 2, and then times 0.7, and then times 9.81. And then from there, we can calculate the distance is equal to 27.78, and then plus 40 meter. Then we can calculate the distance, 42 meter. So from here, we can see that if our reaction time is 2 seconds, okay? If our reaction time is 2 seconds, then actually we have the distance equal to 42 meter, okay? 42 meter, that means if we keep a distance of 50 meter, then it is safe for the dry condition, okay? This is for the dry condition. And then for the wet condition, actually we can do it again. S is equal to Vd and then times T and then plus Vd squared and then over 2 mu G. For this one, actually, again, we know that it is 13 connected, it is the speed of the vehicle. And then assume we have 2 seconds of the reaction time. And then plus Vd squared, again, is 13.89. And then 2 mu is equal to 0.3, and then times 9.81. If you do it this way, you can see that actually this one will increase to 27.78 again, and then plus 32.8. And then from there, you can calculate the safety distance, increase to 15.5 meter. And then it is obvious that if it is under the wet condition, then actually the stopping side distance will increase to 60.5 meter. Okay. So actually, if you keep 50 meter, it is not safe. Okay. So for wet condition, what should our speed in order to give us safe conditions? Say it means that this one is larger than 50 meter. Okay. So it is not safe. Agree? Because in the slogan, it just asks you to give 50 meter of the safety distance. Okay? So it is not safe. So what should be the speed in order to have a safe conditions? If you still remember, we can use the same equation, but instead we will use 50 meter as the criteria here, and then we will back calculate the values of Vd. Right? Then for this one, you can find that VD should be equal to 12.3 meters per second, okay? And then if you turn it back to km per hour, you should multiply by 3.6, and then you should have around 45 meters per second. Sorry, km per hour. Okay. So this one we call that the safe speed when it is in wet conditions. And then for the reaction times, actually sometimes we already mentioned that it involves several conditions. For here, actually, you have so-called four stages for your reaction time. You should still remember. 2-second reaction times, we always mention about that to have 4 stages. If you still remember, we have the so-called sensation. For the reaction time, actually have several components. First one, actually, you have the so-called sensation. So you will actually have some feeling for that. And then the second thing, we call it the perception. And you actually recognize the meaning of the sensation means. And then the third one is actually we call it the situation awareness. And then finally, you have your reaction, response selection. Whether you should stop your vehicle or you should turn your vehicles to the side. So actually, your reaction time will compose of these 4 stages, right? Okay, what are the basic assumptions for the speed of the vehicle AB before the driver decides to overtake the vehicle A in front? So when we derive these equations, or when we talk about this one, do you still remember what we have assumed? So of course, we have assumed that we have several stages, and then we have talked about there's 4 kinds of distance that we need to consider. And usually it is around 16 seconds for a vehicle to take over one from another, okay? So actually there is a very important assumption for this kind of derivation. Do you know about that? Actually, we assume the vehicle A and B will not increase, the speed during the overtake cycle. That means this one, the vehicle A and the vehicle B, actually they do not have variation in their speed, okay? We assume that they are actually in the same speed, okay? Just let you know about that. This is our assumption. And then last one, we have derived the horizontal side distance, okay, about the road. Actually, when there is the obstacle which need to turn around on a horizontal curve. And then we have derived S is equal to square root of R and times D. R is actually the radius from the center of the rod to the center of the inner length. Well, D is actually is the distance between the obstruction and the center of the length. Okay. Now for the derivation, I'm not going to derive again. Actually, you can take a look in the notes. So for this one, I think you can do it by yourself and take a look for the derivation of the equations. But for the derivation, I may, maybe in the examination, I may have some kind of simple derivation for you, and then ask you to derive the equations, okay? So you should also take a look for the derivation of those kind of equations as well. And then for the last one is a curved section of row owns a radius of 100 meters. Say for example, if we have a row actually it's a curve here, and then actually if it has an obstacle, say for example, we have an obstacle here, and actually if you take a look from here to here, actually it's a horizontal distance, then you can take a look. But for the real distance, actually you will travel around from here to here. So actually S is the distance along the road that you will travel when you can see the obstacle from this point to the other point. So R is actually the distance from here to the center of the road. This is R. And then the D is actually from the center. So here is actually the D. That means from here to here is R. This one is R minus D. This is the inner length of the road. When the vehicle is going around, and then you will see that actually something is right here from this point to the left-hand side, and the right-hand side, you will see that there is something ahead, and you want to stop your vehicle. And actually, the real distance that your vehicle will travel is S, okay? Then actually, S is equal to square root 8 and then times RD. R is the radius from the center of the length to the center of curvature. Well, D is actually from the side of the road, or we can say that it is the obstruction. And then to the center of the length. So this is the obstruction. Okay, now we have a question. A curved section of road owns a radius of 100 meters. That means R is equal to 100 meters. And the edge of a building located 5 meters from the center of the length. That means D is equal to 5 meters. This is R is equal to 100 meters, and then D is equal to 5 meters. Suggest the design speed limit for the curved section of the road. Assume mu is equal to 0.3, while the reaction time is equal to 2 seconds. So actually you are turning around on the horizontal curve, and then the radius is 100 meters, while the D is equal to 5 meters. And then you know the friction is equal to 0.3, I mean friction coefficient, while your reaction time is equal to 2 seconds. Now, what does that mean? That means your vehicle is going around, then actually your vehicle, when you see something ahead, you need to stop the vehicle, and then the real distance you travel is s, okay? Then this one becomes your stopping sight distance. Do you agree? Because actually when you see something ahead, you want to stop the brake, and then you want to stop your vehicle, not hitting to something ahead, right? So s is actually the real distance that you will stop your vehicle. So this s should be equal to your stopping sight distance. Do you agree? So the stopping sight distance is actually equals to the reaction time times the speed of your vehicle plus the braking distance. So from that, you can calculate what is the design speed of the road. Okay? You know what I mean? So the stopping sight distance is actually equals to the VD and times T plus VD squared 2 mu G. We have used this one before, right? This one is the reaction distance plus the braking distance. And then this distance should be equal to S. S, we call that the horizontal sight distance. That means it is the vehicles that will travel when you see from here to here. That means this is the real distance that your vehicle will travel. S, okay? And the distance should be should be equal to your stopping sight distance, because your vehicle will stop within this distance. Otherwise, you will hit something ahead, right? So by using these two, actually, you can calculate what is the design speed of your road, okay? So you have mu is equal to 0.31, t is equal to 2 seconds, okay? Okay, just spend several minutes and then think about how to use this equation to find out your design speed, and then we can do it together. Because actually your vehicle will travel S when you see something ahead, right? That is that is something here. And then actually your stopping sight distance consists of two parts. The first one is due to your reaction. And then the second part is your braking distance. This distance should be equal to your horizontal sight distance, right? The S should be equal to your stopping sight distance. Because when you see something ahead, you have to brake your vehicle. You have to stop the vehicle. And then when you stop your vehicle, then it consists of two parts. One is the reaction, and the other one is the braking distance, right? 即係你一睇到你就想停啊嘛，所以你嘅 distance 應該一樣。 Okay, so for this one, it should be quite direct for you to find the answer, because the two should be the same, right? So when we finding this one, actually we just make sure that they are the same. So actually you will have your horizontal side distance, which is actually the S, will be equal to your stopping side distance. So this one S is actually equal to square root n times 8. And then we know that n times RD. R is the radius of the curvature, and D is the distance between the obstacle and then the center of the length, which is actually equals to the VDT plus the VD square and then over 2 mu G, right? Do you agree? These two should be equal. Because when you see something ahead, you should stop your vehicle, okay? And then the distance that you will travel actually is square root 8 times RD, right? Do you agree? So for this one, you just calculate and then find the value square root 8 and then times 100 and times 5, right? So for this one, okay, so for this one is equal to what is the answer of a problem? Okay, so it is 60 feet on 2 meters, right? Then it is equal to VD and times T. T is equal to 2 seconds. And then plus VD square, and then 2 times the mu is equal to 0.3, and then the G is equal to 9.81. And then for this one, you can back calculate the VD value, and then this is the quadratic equation. So if you're going back, VD is actually equals to around 14.3 meters per second. Around 51 km per hour. So for this one, you may say that the design speed is around equal to 50 km per hour. Okay, and then we can take a look to the second part. If the design speed has to maintain at 70 km per hour for that whole section, what suggestion would you make? Now, right now, we just calculated that the value actually is equal to around 50. But if you want to maintain it as 70, so what you suggest to be modified for the road so that you can keep the design speed to be 70? But first of all, if you have high design speed, what will happen? You should have longer side stopping systems, right? Do you agree? Because if you have higher speed, your stopping side distance will be longer. Okay, for the same reaction time, because the speed is higher, then you will take a longer distance to stop your vehicle. Do you agree? Then actually you need to modify your curve in order to satisfy this longer stopping side distance, right? Do you agree? So for the horizontal curve, actually controlled by R and D, okay? So you may either increase R or you may increase D, okay? Do you agree? So can you take several minutes and then try by yourself? What should be modified for maybe for your R and then for your D? Say if you want to have your design speed at 70 km per hour, then can you make some suggestion for modification of the curve of the road? Now remember, for this kind of calculation, you're also doing in a meter per second, okay? So please change it from km per hour to meter per second. Then you can perform your calculations. So for here, actually, again, you will change the first 70 km per hour. And then change it. You have 70 per km per hour divided by 3.6. It becomes 19.4 meters per second. Okay. This is the speed. Okay. So if it is 19.4, then what is the stopping side distance? So the stopping side distance actually is equal to the speed and then times the reaction times and then plus the VD 19.4 square and then 2 mu G. And actually it's equal to 102.7 meters. So what does that mean? That means if you have 70 km per hour, then actually your stopping side distance will increase to 102.7 meters, okay? Then this one should be equal to the horizontal curve distance, okay? So for this one, well, actually it is equal to 102.7 and then equal to square root 8 and then times R, right? Then for this one, actually, you may change. You may increase the design radius of the curve while keeping the distance between the center line of the inner link and the building to be the same. So option 1 is that you will increase the design radius. So you still use 102.7 and then which is equal to 8 and then R, we don't know about that. And D is actually the distance with U5. Then you can find out the values of R. Actually, it is equals to around 263 meters. Now you can see that the radius will increase quite a lot. Now originally it is just 100 meters. But if you want to increase the speed from 50 to 75, you can see that the radius is largely increased. So actually your curve will be much, have a larger distance than before, quite a lot, okay, more than double. And option 2 is that you may increase the distance between the obstacle and then the center of the interlink of the road. Then again, 202.7, which is equal to square root 8. And then R, you will keep 100. And then the distance, D, you will make it to be variable. And then you can find that D is equal to 13.2 meters. Then actually you may increase the R or you may increase D, okay? So you have two options to modify your curve in order to satisfy this criteria. Okay? Do you agree? Okay, let's take a 5 to 10 minutes break, and then you may come back, and then we can have our next chapter. Okay?
咧，頭先講我要即係要 chase 翻即係份 assignment 會 chase 翻5至10年嘅嗰個 rate 嘅，但係我哋抄咗嗰份 annual report 啦，咁但係我哋發覺到2021年同2020年都已經有唔同啦，就係 Plan C 嗰度，即係個 session 個計法都唔同咗啦。咁但係咁我哋咁樣咪好難 chase 翻5至10年嗰個。
佢有同一個 station number 喎。
冇啊，因為佢會變晒咯。係啊，即係如果你可以過嚟睇下，因為我哋睇就
你揾翻 similar 嘅 session 嚟啫。即係咧，你冇辦法㗎，因為佢可能變咗都唔定。你睇翻之前。如果佢有嘅有咯，即係你可以攞，係啦，攞到你都係攞即係可能用方法，我即係同時嘅用，咁佢話你解釋喺度，咁你睇事實係我。即係四番，即係你咁講，即係睇到咁大方啊！即係可能呢個即係嗰個點樣去數錯佢行咗嚟，都係我咁你話我哋。同埋咧就知道嗱你啱啱我你係如果即係可能兩個地方可能我依家可能打上個我有好多地方即係香港所以你睇下即係睇翻我咁你而家10嘅係你而家10嘅你睇啦，但係你頭先話有差唔多咗咁你咪將咁多我啲人聽即係有可能有一個你將呢一個即係用呢一個範圍喂3%、7%、3%咩高啫？可能有幾多？但係你唔知啊，可能咁你90%啦，嗰啲人方面咁你有3個即係睇下佢哋多有少多同埋8落係啦，咁你就開一張即係可以做個少少嘅資料啦。而家可能係一個問題，咁佢都要等等。佢將來講一3個禮拜啦，雞係嗰2個禮拜啦。我知問題真係如果人嘅揸我哋叫喂，雞即係話大家係用啲呢個可以啦，你請嘅。哇！我大家從得咯， 試唔到考試啦。我再問你再問咧，你哋到到考試啊？因為你10做考試啦，你嘅手
Yes.
How many questions are in the midterm?
Around 6 to 7 question and answer, and then maybe around 2 for calculation. Okay. Because actually for question and answer, you can think of, if you know the answer, then you can write it down quickly. If you don't know the answer, then you can just blank. Or you can say something, you can write something that based on what you understand. So, I can't document that because you know that you do right for example. And then I don't think the calculation is very difficult. Because actually it's more time bar and then time plate. And then you have to work with those how to read the power concept and all that. And then the next design, what how to do those calculations. Then the problem that try to understand how to find out all you understand the way. There are actually not difficult questions. Because they are just kind of design. Design usually just follow the steps. So you can look at Excel and see whether you understand the steps or not. So I don't think it's very before the I think the thing you can memorize all of the information the state of understanding that right now and that only memorize all of it. Otherwise of course for some technology say for example expression from home we will go most time if you have technology you cannot create yourself. You cannot say technology small, very small, you cannot say it's small. Those kind of technology. Okay, after the horizontal curve, then we have a new chapter today. Actually, it's about the so-called vertical curves and then the super elevations. But actually, for the roads, it consists of horizontal curve because when you are going around some obstructions, you need to have the horizontal curve and then to pass around all the obstructions. And then when you're going up the hill, and then you are going down the hill, of course you also need to have some, we call it a vertical curve, okay? Say that you from one gradient to another gradient, then of course you will create a curve in between. saying that you are climbing the hill, then you may go from lower or smaller gradient and then to higher gradient, okay? Of course, there will be the vertical curve. And then when you pass the crest of the mountain, and then you are going down the hill, of course, there is also the vertical curves. And at the same time, when you're turning around for a particular road, in order to maintain the speed of the vehicle, there are always so-called super elevations. In order that the sail weight of the vehicle can help the turning around of the vehicle as safe as possible. So for this chapter, we will mention about the vertical curves, and then we also mention about the super elevations. We have some kinds of calculations and derivation as well. And then we will have some examples to illustrate what is the distance of the vertical curve in order to provide enough side safety distance. So first of all, we will have some terminology for this chapter. Again, we have the so-called design speed. Actually, it's the maximum safe speed. Assume the near worst case conditions. That means the wet weather conditions. So actually, the design speed is the maximum safe speed. You cannot exceed this. We call that the design speed. Otherwise, it becomes not safe. Okay. And then we have also the so-called average vehicle running speed. Usually, this one is obtained from the actual vehicle speed observation under low traffic volume conditions. So this one may not be the design speed. Usually, it is 83% to 100% of the highway design speed. So it is lower or slower for the vehicle. So we call that average vehicle running speed. And then, as I mentioned, we have the so-called the stopping sight distance. Stopping sight distance is actually the distance that the vehicle will stop. It includes the so-called reaction distance and also the braking distance. And then for this SSD, for the minimum stopping sight distance, is actually derived from the average running speed. That means the speed is slower or is lower. For the desirable stopping sight distance, that means we want the stopping sight distance that we want. It's actually SSD derived from the design speed. So of course, if we provide larger stopping sight distance, so actually it will be safer. So actually it will be derived based on the higher speed. So it will derive based on the design speed. Actually, in the code of practice or in the US, actually they have the so-called the stopping sight distance. Actually, it depends on, as I mentioned, it depends on the braking distance and then reaction time. So if the design speed is around 30 km per hour, then the stopping sight distance for design is around 29.6 meters. And then for the speed up to 60, and then you can see that the stopping sight distance is around 74.3 to 84.8 meters. So that means if you are driving with a speed of 60, your stopping distance will be around 74.3 to 84.6 meters. So actually your road should provide this kind of distance in order to avoid the accidents. Otherwise, if the distance is shorter than the stopping sight distance, then actually you will hit the vehicle ahead, and then you will have accidents. So for the stopping sight distance, and then we should provide enough length which should be equal to the stopping side distance, so that the accidents can be avoided. So longer length of the curve provide more SSD, but it is more costly to construct. Now, of course, if we provide a longer length, it will be safer. But if you provide longer length, then actually it is more expensive. Okay? Of course, if you provide shorter curve length, and then it's relatively expensive. However, you may not provide enough stopping side distance. So actually, you need to provide a minimum curve length, and then which give a required stopping side distance. For this one, actually, we have already calculated for the horizontal curve. As I mentioned, S is the horizontal curve distance, which should be equal to the SSD. In order that the curve length should be equal to the SSD. But right now, we will mention about the vertical curve. The horizontal curve is actually you have something here. You have some obstacle here, and then you will turn around of this one. So this one is the horizontal curve. Then we just calculate that from here to here. We will have the distance equal to S, which is the so-called horizontal side distance. Because when you see something, actually you will see it horizontally, but your vehicle actually will travel along the curve. And then this horizontal side distance should be equal to the stopping side distance. Because once you see something ahead, you should stop your vehicle. And actually it is equal to the stopping side distance. Then this is the horizontal curve. And then the vertical, actually you also have similar situation. If you have a vehicle here and then you see something ahead, there, and actually you have a distance here, this is again your side distance. And then actually you have to provide enough length of the vertical curve, because this one, when you have one vertical curve to another vertical curve, actually you need to go over the so-called vertical curve. This one is the vertical curve. So it defines the change of the vertical curve here from one tangent to another tangent. This is a one gradient, this is grade 1, and this is gradient 2. When your vehicles pass from one gradient to another gradient, you need a so-called vertical curve. And then it defines as the start of this curve and then the end of this curve, and then this one we call it the length of the vertical curve. And then actually we need to provide enough length of the vertical curve so that it can provide enough SSD in order to avoid accidents to occur, just like the horizontal curve. Because your vertical, the vehicle will go around from here to here to the other side, okay? And then actually we need to provide enough length for the vertical curve so that the length is equal to the SSD. Then, well, you will have a safety distance to stop your vehicle, okay? Because horizontally you will move around the curve, and vertically you will also move above or below or on the curve, because your vehicle will also move along the vertical curve. So the length of the vertical curve should give enough distance for the SSD. Because once you see something, you have to stop your vehicle, right? And then, well, your vehicle will see, you sit in the vehicle, you will see something ahead. And then when you see something on the other side, actually you will stop your vehicle. Do you agree? So the length of this vertical curve, this one is the start of the vertical curve, this one is the vertical curve. The start of the vertical curve and then end of the vertical curve, this is we call the length of the vertical curve, should be equal to the stopping side distance. So this length should be equal to the stopping side distance. Okay. If it is equal to the stopping side distance, then you can stop your vehicle and then avoid the accidents. If the length of the vertical curve is too short, then once you see something ahead, say for example, you need 50 meters to stop your vehicle, but the length of your vertical curve is just 40 meters, then you will hit something ahead. You know why? Because the stopping side distance, as I mentioned again, it involves the reaction times, and then it involves the braking distance. This is the side stopping distance. If the length of the vertical curve cannot provide enough length, then your vehicle will hit something ahead, because you do not have enough time to stop your vehicle. The length is too short, okay? So that's why we need to calculate the minimum curve length, okay, to give a required SSD. But say before talking about the length of the vertical curve, so why we need to have the vertical alignment? As I mentioned, the vertical alignment, because actually there's different gradient when you go along the road. And then saying that actually your road is something like that, and then you have a different gradient. And then so you first gradient here, and then your second gradient here, and then your third gradient here, fourth gradient here, fifth gradient here. So this is your first gradient, this is your second gradient, this is your third gradient, fourth gradient, and the fifth gradient. So when you go along your road, actually you have different gradients. And then actually this is, we call that the vertical curve, when you have the change of the gradient from 1 to 2, and then from 2 to 3, and then from 3 to 4, and then from 4 to 5. This one are actually the vertical curve, which connect different gradients, okay? Because actually you will have your vertical alignment along the road. And then you should have transition from one-to-one for the driver comfortably, and it should be smooth, and you should do it economically, okay? Now, of course, you may always use one gradient, okay, from one here to here, okay? You can always cut, and then you can fill to eliminate the rolling nature of the length, okay? You can always use one from here to here, right? Because you just from this point to this point. But you can think that you need to cut, and then you need to fill all the things, and then it will be very expensive. So sometimes we allow the road have some kind of gradient. Actually, you can fill all the road and then to make it flat, right? But it will be very expensive. Or you can cut all the road to make it flat, right? You can always cut and then fill, okay, to eliminate the rolling nature of the land. But if you say that you will cut all the things here, then you think that you need to cut the slope and then make it flat, it will be extremely expensive, okay? Or you can fill all the things here and then make it flat again so that your driver can do it comfortably. But of course, this one is also not economical. So instead of doing this kind of things, we will use the so-called vertical curve to connect different gradients together. And then of course, for the road, we will have some kind of permissible vertical gradient. Okay, we allow it to have a kind of gradient so that you do not need to cut the slope always. You can allow it a certain gradient. Otherwise, you need to always make your gradient flat. It will be very costly, okay? So in order to have good transition from one gradient to another gradient, we should provide a so-called vertical curve. But this curve, sometimes they can be convex, and sometimes they can be concave. Like if two grades or two gradients, they meet the so-called summit, then we call it a concave curve. If the grades actually meet and then make a sag, we call that a concave vertical curve. Now I will show you what is concave and then what is convex very soon in the next slide. But generally, vertical curves are not considered necessary when the total grade change from one tangent to another does not exceed 0.5%. If there's just a little bit changing of the gradient, you may not provide a so-called vertical curve. But when the gradient exceeds 0.5%, we should provide vertical curve so that it will provide a so-called comfortable transition from one to another. So here actually is the summit curve which requires a change in the situation. A positive curve means a negative grade. So for the first one, you can take a look here. But always we mention that positive something like this and then negative something like this. So a positive means a negative grade means the first one is something like this. Positive means a negative one. Okay. So we call that summit vertical curve. A positive means a negative. Or we can call that this one is convex. And then sometimes we have a positive grade, still positive, but it meets another milder positive grade. That means both of them are actually positive. But the first one is more positive than the next one, okay? So here there will also be a so-called vertical curve here, because they connect the two together. This one should exceed 0.5%, so we need the vertical curve. And for the third one, actually, it's a positive grade, it's a level stretch. That means you can see that it's a positive grade here and then meet at the grade of 0. So this one is also a summit curve. And then if both of them are negative, we also have the concave, convex vertical curve. If it is a negative grade, it is a deeper negative grade, then we will have this kind of correction. Then you can see that it is negative, and then this one is more negative. Then we have the so-called summit curve again. And then for here, for the next one is the sag curve. Sag curve is actually a negative grade with a positive grade. Negative means that this one is negative, and then we can read a positive grade, something like that. So it just acts like a sag here. This one just like a concave, convex, sorry. So for here, you can see that when we have a negative grade on the left-hand side, and then we have a positive grade on the right-hand side, then we have the so-called sag curve. And then if we have a negative grade and then meet a milder negative grade here, then we have the so-called the sag curve again. The same right here, we have a negative 1, and then we have a level 1. And then finally, we have a positive 1, and then a more positive 1. Then you will have the sag curve again. So we call that this kind of vertical curve as different names. And then usually these vertical curves are in parabola, okay? Because this is a more easy transaction and it is more comfortable. So for here, in order to determine the length, well, you usually consider some factors. First of all, while we consider the controlling factor, first of all, is always the safety. And then the second is the comfort. And the third one is the aesthetic consideration. Well, for this kind, as I mentioned, for this kind of vertical curve, usually we will choose them as a parabola. And then this one actually is a usual way to adopt, because actually it gives a comfort transition from one gradient to another. And then the length of this curve is usually governed by the side distance. And usually this side distance should be equal to the stopping side distance. Because actually, as I mentioned, the length of the vertical curve should be enough to provide the stopping side distance so that the vehicle will not hit on the obstruction ahead. So we will derive the length of the vertical curve very soon. Actually, it depends on the side distance from the vertical curve. And then for the gradient, actually, is the allowable gradient is equal to 4% for the trunk roll and then primary distributor. And then 5% is the desirable maximum. That means when you design your roll, usually 4% and 5% is the appropriate gradient. And then, if necessary, we should also provide a sort of absolute maximum for both the trunk roll, primary distributor, and then for the others. But usually, we will design a roll to be 4% and 5% if possible. And as you can see here, you have a vehicle, and then there's a vertical curve here. PVC is actually the start of the vertical curve, and then PVT is actually the end of the vertical curve. And then L is actually, we call it the length of the vertical curve, while S actually is the side distance. And then actually, as I mentioned, side distance is the distance that the vehicle needs to stop. When you see something ahead, once you see something ahead, you should start your braking and then stop the vehicle. Then actually L is the length of the vertical curve. And actually the length of the vertical curve should be enough to provide enough distance so that your vehicle will stop. L is actually the length of the vertical curve. So in this situation, we can see that L is smaller than S, right? So in this case, well, we will use the equation below. AS squared over 200 and then times square root h1 plus h2 and then square. This is actually the minimum length of the vertical curve. That means if the length of the vertical curve is smaller than S, you should provide Lm is equal to A times S squared over 200 and then times square root h1 plus square root h2 squared. H1 is actually the height of the eyes of the driver, while H2 is actually the height of the obstructions. So if you have this condition, you can calculate Lm by this one. So the Lm is the minimum, we call it the minimum vertical curve length. And then this minimum vertical curve length is actually equals to the SSD. We call it the stopping side distance. Well, actually A is equal to algebraic difference between the two curves. A is actually, you can see that if you extend the tangent line from the left-hand side, and then you extend the tangent line from the right-hand side, A is actually the difference in the gradient. And then you can derive the LM is actually equals to the expression above. Now for the side distance S, actually it should be provided and then equal to the SSD. The current is Ashton design guideline. It gives a user driver eye height of 1.07 meter. And the roadway object height actually is equal to H2, which is equal to 150 mm. The H1 is actually the height of the driver eye height, 1.07 meter. And on the right hand side, H2 actually is equal to 150 mm. So if you put H1 actually equal to H2, I mean H1 is equal to 1.07 meter, while H2 is equal to 150 mm. To the equation above, actually you can find that the value will be equal to these expressions. So you just substitute H1 is equal to 1.07, and then you substitute H2 is equal to 150 mm. Then you can find that LM is equal to 2SSD minus 404 over A. S is actually equals to SSD in this case, because actually your S is the side distance. The side distance should be equals to the SSD. When you see something ahead, then actually the side distance should be equals to the stopping distance, which actually belongs to the so-called the braking time plus the reaction time, right? So SSD is actually equals to the stopping side distance. This one it should be equals to the SSD. And then you should provide your length of the vertical curve so that S is equal to SSD. Do you agree? Because when you have the curve here, this is start the curve, this start the curve, this is the length of the curve. And then when your vehicle is here, and then you can see something ahead. And then this is your side distance. And then when you see something here, you will start to stop your vehicle, right? And then this distance should be equal to your stopping distance, which involve reaction times and then the braking time. And then we just want to calculate L, so then you provide the S, and then the S will be equal to the SSD. And the S can be longer than L, or S can be shorter than L. So depends on the situation, we will put, or we will use the first equation, or we will use the second equations. Okay? You know what I mean? Because you have the start of the vertical curve, and then you have the end of this vertical curve. And actually S is the side distance. And then this side distance is that you can look the obstruction ahead. So this S should be equal to your stopping distance. You involve braking time and then reaction time, okay? So when you see something ahead, this is the side distance. It should be equal to the sorting side distance. If the side distance is shorter than SSD, what will happen? When you see something, then the distance is too close, then you do not have enough time to stop the vehicle, right? Then you will hit on the fence ahead. So S should be equal to SSD. And then L is actually the length that you have to provide for the vertical curve. So that S is equal to SSD. And then you know that actually the vertical curve is a parabola. Then you can derive this equation. Now, I'm not going to show the derivation for this one. You just need to use the equation. When S is larger than L, then you will use the first equation to find the minimum vertical length, Lm. When S is smaller than L, that means the side distance is smaller than the length of the vertical curve, then you will use the second equations. Now you may ask, hey Simon, how come I know S and how come I know L? Which condition should I use at first? Because I don't know what is the L. Now actually you may assume one of the conditions first, and then you can calculate the values of L. Then you may find the values of S, and then you will compare whether S is really larger than L or not. Now we will have an example to show you how to use these two equations. So if we put h1 is equal to 1.07 meter, then actually it is an h2 equal to 150 mm, then we will have the first equation, and then we will have the second equations. So SSD, as I mentioned, it involves both reaction distance and then it involves a braking distance. Like if we are going up the hill, then G is the gradient, right? If we are going up the hill, do you think we have more or less SSD? Should we use plus or should we use minus when we are going up the hill? When we are going up the hill, actually we can have less braking distance, okay? Because the gravitational force will pull you back, right? So you should use plus, right? Because it is a denominator. Otherwise, if you're going down the hill, then your SSD will be longer. Then you will use a minus when you are going down the hill. Do you agree? So here I give you an example, and then we can take a look together. The highway is being designed to AASHTO guideline with 120 km per hour. That means the design speed is 100 km per hour. In one section, an equal tangent vertical curve must be designed to connect rate of positive 1% and negative 2%. That means one side of the road is plus 1% in gradient, and the other side of the road is negative 2%. Determine the length of the curve required. Assume the position will be of minimum SSD. And then maybe we can try to use the minimum SSD first. Now right here, we want to determine the length of the curve required. So we will use these two equations. Either the first one or we will use the second one. So for here, we need to try and then to see which one that we are going to use. So first of all, because actually we want S is equal to SSD, right? So first of all, we need to know what is SSD. For here, SSD is actually the stopping side distance. But as I mentioned, we have plus or minus. SSD, you know that actually it is equal to VD and then times T plus VD squared and 2 mu G, right? And then for the 2 mu G, we have plus or minus G here. And then right now, you know that we have plus or minus. Now you can going up the hill or you can going down the hill. Now actually, we will use a more conservative distance for our design. Do you agree? Now you have one gradient is going up the hill, and then you have one gradient is going down the hill. For a more conservative design, which one will you use for your gradient? You have plus 1%, and then you have negative 2%. So which one will you consider when you have your design? Will you use plus 1% or will you use negative 2%? For safe stopping side distance or for minimum stopping side distance? Will you use one going up the hill or will you use one going down the hill? Maybe I just ask, will you use plus 1% or will you use negative 2%? Yes. If you use 1%, please raise up your hand. How about negative 2%? Okay, I have one answer on the class. Okay. Okay, why I need to use negative 2%? It is more conservative, right? Because I should not use plus 1 because it is going up the hill, right? So the stopping side distance should be longer, right? If I'm going down the hill. So I will use negative 2, okay? So right here, we will use negative 2. Now 120 km per hour is the design speed. So I need to turn it to meter per second. So I will divide by 3.6 again, right? So if I divide by 3.6, it is equal to 33.33 meter per second, okay? So again, 33.33, I assume that the reaction time again is 2 seconds. And then VD is actually the design speed again, so it is 33.33 and square. And then I have my mu. Mu is actually the friction coefficient. And then I assume it is equal to 0.3. And then it is minus 2%. So for here, it is equal to 66.66, then plus 202.22. So I can see that the SSD is equal to 268.88 meter. So first of all, I will calculate what is the SSD first, or side distance. Okay? Saying that if I'm going down the hill, I need a stopping side distance of 268.88 meters. Then right now I'm going to determine what is the length of the vertical curve, so that it will provide a side distance equal to this value. Now I have two equations, if you still remember. I have one equation is that S, or right now S is actually equal to SSD, is larger than L, or I have SSD is smaller than L. Now I don't know whether it will be larger than or equal to the value, right? Because they are actually unknown, okay? So I don't know the answer. So for that, actually, I will assume the first conditions first, because I don't know whether it's correct or not, okay? So I will assume SSD is larger than L. So I will use this equation, 2S minus 200, and the square root of the value. As I mentioned, we will use the Ashton criteria, so I will just substitute x1 is equal to 1.07 meter, and then while h2 is equal to 0.15 meter, that means 150 mm, and then square divided by A. A is the algebraic difference. So one is 1%, the other one is -2, so the difference between the two gradients is equal to 3. So I will divide by 3. And then if I substitute the values, S is equal to 268.88. So it will be equal to 537.76 minus 404. Then divided by 3. And then I can find that LM is equal to 403.09 meter. But this is the length of the vertical curve. And then you can see that for this one is larger than SSD. So do you think this one can satisfy our assumption? We assume that SSD is larger than LM, right? But finally, we find that LM is larger than SSD. So what does that mean? Our assumption is not correct. Do you agree? Because you want to find the length of the vertical curve so that it can provide enough side distance. And then that means the first criteria cannot be met. So we should use the equation 2, right? And then we know that for the equation 2, actually, we can adopt the this one as well, because we know that if we put h1 is equal to 1.07 and h2 is equal to 0.15, we can get this equation. A times SSD squared and divided by 404. You agree? Then we just substitute this value. Then you have the values of LM is equal to 536.9 meter. Then this one is larger than your SSD, which is equal to 268.88 meter. Then it can satisfy your requirement. That means the length of the vertical curve should be equal to 536.9 meter. That means the length of the vertical curve here should be equal to 536.9 meter. And then the side distance is actually equal to this. Which is equal to 268.88 meter. So the vehicle has to go inside the vertical curve, and then the vertical curve actually can provide enough side distance, which is actually equal to the SSD. Okay. You know what I mean? So the length of the vertical distance should provide enough SSD. And therefore, the sag curve actually have a similar criteria. So you can see that this is the side distance from the vehicle and then to the things above. Now you can see that actually, if it is in the daytime, there's actually no limitation or no restriction for the S, because actually there's nothing ahead, because on the vertical curve, if it is a summit curve, actually because of the vertical curve itself, it will obstruct the sight or the view of the driver. But for the sag curve, actually the driver can always see ahead, and then it is not a problem for driver to see when it is in the daytime. However, if it is at the night time, actually then it depends on the light of the vehicle. So for here, you can see that there's a beta there. Actually, it is the angle between the light of the vehicle and then the horizontal curve. So you can see that it is a beta. And then it can be derived that LM is equal to 2S minus 200, and then H plus S times tangent beta over A. Again, A is the difference between the two tangents. And then beta is the angle of the beam light of the vehicle, while S is the sight distance, and H is the height of the light of the vehicle. Again, there's one expression for S larger than L, and then there's an expression S smaller than L. But for here, actually, again, the sag curve differs from the crest vertical curve. There's actually no limitation if it is in the daytime, as I mentioned, because there's a daylight. So for this kind of sag curve, actually depends on the so-called nighttime conditions. Well, if your vehicle has different headlights, height, h, and then angle of headlight beam, beta, then of course you will have different answer. But for the AASHTO guideline, actually the design, the headlight height is usually 0.6 meter, and then upward angle of 1 degree is assumed. If you substitute the values into the expression, then you will have these two expressions here for SSD larger than L and SSD smaller than L. And actually, you can also find out the setting out of the vertical curve. Saying that you have your first point here at the T1, that means the gradient 1. Then T2 here is actually the gradient 2. And then if you treat the T1 here as the coordinate, the origin, you can always find the x coordinate and y coordinate of any point along the curve. So for here, actually, you can derive the curve actually like that. You can determine all the coordinates of the points along a parabolic vertical curve like this. Y is actually the y coordinate, which is equal to q minus p, and divided by 2l times x squared. While x is actually the coordinate, x coordinate of any point on the vertical curve. P is the gradient on the left-hand side, while Q is the gradient on the right-hand side. And then E, we call that the vertical offset at the intersection point PI. E is actually right here. Assume that the straight line actually can extend, and then assume the line can extend on the other side as well, and then find the intersection. And then E is actually the distance between the intersection and then the curve. The coordinate, the highest point of the curve, is actually can be derived as LP over P minus Q, and then LP squared over 2 times P minus Q. This is the highest point of the curve. And after about the vertical curve, actually we also have the so-called super elevation. When you turn around on the road, as I mentioned, for horizontal curve, now basically, if you try to drive, you know that when you are turning around on the road, actually you will have a centrifugal force applied on the vehicle. You can feel that your vehicle is actually along the road, and then you want to leave the road, okay? You can feel that actually your vehicle is sliding away from the road, and it slide out towards outside of the road. Well, actually, because from physics, actually you know that when there's a circular motion, then there is the so-called centrifugal force. You need to actually have a force to pull your vehicle when you turn around on the curve. So for the vehicle itself, actually you can feel a horizontal, force, which is mv squared over r. M is the mass of the vehicle, while v is the velocity of the vehicle, and r is the radius of the curve. So that means when your vehicle turning around on the curve, actually there will be a centrifugal force, and then to act on your vehicles. So here actually is a mass m kg. We call that there's a vehicle, there's a mass m kg here. So you will always have the mg applied on the vehicle. And then saying that you will have a v meter per second going around a horizontal curve with a radius r. Then you will experience so-called outward force of mv squared over r newtons. This is due to the circular motion of the vehicle. And we call that mv squared over r. So for here, you have the force applied on the vehicle. So here actually is the force diagram. So horizontal